Bismillah ar-Rahman ar-Rahim. Good morning, everyone. Welcome to today's seminar related to a topic on artificial intelligence. We were happy to invite our guest speaker, Professor Jonas Vitas, who is with us today to talk about one of the recent topics related to artificial intelligence, and also to give us a brief idea about the International AI Doctoral Academy. So it is my honor to introduce Professor Jonas Vitas, who received his diploma and PhD degree in electrical engineering from Aristotle University in Greece. He has been professor at the Department of Informatics and Director of Artificial Intelligence and Information Analysis Lab. He served as a visiting professor at several universities. His current interests are in the areas of computer vision, machine learning, autonomous systems, intelligent digital media, image video processing, human-centered computing, effective computing, 3D imaging, and biomedical imaging. He has published over 900 papers, contributed to 46 books in his areas of interest, and edited and co-authored 15 books. He has also been a member of the program committee of many scientific conferences and workshops. And in the past, he served as an associate editor or co-editor of 23 international journals and general technical chair of 5 international conferences. He delivered more than 100 keynote and invited speakers worldwide, and he co-organized 38 conferences and participated in technical committees of more than 200 conferences. He participated in more than 75 R&D projects, primarily funded by the European Union. He is also the chair of the International AI Doctoral Academy, and he was a chair and initiator of the Institute of Electrical and Electronics Engineers, EAAA Autonomous Systems Initiative, and he has more than 37,000 citations of his work and an H-index of more than 91. According he is ranked first in Greece and 319 worldwide in the field of computer science in the year of 2022. So given his expertise in artificial intelligence, we are sure that his talk will leave us with a new perspective and practical insights into how AI is reshaping our daily life. So please join me in welcoming Professor Jonas Vitas. Prof, welcome.
Okay, ladies and gentlemen, it's my honor to be invited to give a lecture here at Oman on artificial intelligence. So essentially, I'm going to make 2 presentations. The first one is going to be the presentation on the International AI Doctoral Academy, and then I'm going to give a scientific lecture on the applications of artificial intelligence and big data analytics on natural disaster management, because one of our, in the European Union, we have a project called TEMA on AI for natural disaster management, and one of the companies that participates in this project is a Dutch company on flood management, and they have business here in cooperation with Omanis, because I think that you have flash flood problems that have to be tackled. So that's why part of my lecture is going to be on flood management and how you can accommodate these problems. So I start first of all with the International AI Doctoral Academy. I have some leaflets down there, so if you want, you can get them. The International AI Doctoral Academy is about AI education at high level. And AI education is a very important topic these days, because it transcends all scientific fields and it's global. So that's why we have to be educated, all of us, or re-educated and reskilled in things that are related to AI. So the European Union had this initiative, and we applied for it, to develop AI doctoral education. So this means that that we offer through IDA doctoral education at the highest level. So PhD education, postdoc education, and also master student education. So I'm going to make you a brief presentation for activities there. Your university applied to become associate member of IDA. I did not have time to act on this because we are currently reviewed by the European Union, who funded IDA, but I hope that pretty soon your university is going to be associate member of IDA, which is equivalent to be full member, because in IDA all decisions are unanimous, so basically voting or non-voting doesn't make any much of a difference. So that's why I would welcome not only SQU but also other international universities to join IDA, because all of us can benefit of the globalization of AI education. So here you see some operational highlights regarding IDA. So far we have already 80 members, because these slides were produced in June. In the meanwhile, we had 2 more members. Actually, we had 60 AI universities from all over the world, and then another 20 R&D centers and companies. We covered the entire Europe and beyond, because AI education is global. And essentially, we try to deliver high-level lectures, short courses, summer schools. So far we had about 160 lecturers from all over the world that delivered IDA courses. We have IDA students from our members. For example, if SQU becomes member of IDA, then some of your PhD students or postdocs can become IDA students and get certificates about their AI education. We deliver, within 3 years, we delivered around 90 courses so far, because these are already old figures, and also we delivered a large number of summer schools. The next summer school is going to take place in Greece in July 2025, and it's a joint symposium and summer school, in the sense that it's going to contain about 20 invited speeches on things related to AI, plus another 25 tutorials and short courses on various topics of AI. This is going to take place in July in Greece, so you are welcome to join. Greece is beautiful in July. Maybe here is too hot. In Greece is hot as well, but maybe less humid. So it's a pleasant period to visit Greece, and also at the same time to be trained and be educated in new AI topics, because all lecturers in this event are top-level scientists from all over the world. So it's going to take place in the first half of July. We try to promote lectures that we have a series which is called the AI Excellence Lecture Series, and I'm going to tell you more on this. And then we have also educational resources that we gather, so that when you enter the IDA webpage, you can have a wealth of material to be used for AI education. We have been very active in social media, because we use social media to promote all these events of our members, of IDA members. So to start with, you may have noticed that all over the world, in many universities, we now have AI departments, and we have AI studies, bachelor studies and master studies on AI, and this is done very fast, and people, don't know how to essentially create an AI curriculum. So IDA created an AI PhD curriculum, but it can be used also for bachelor studies as well. And it is a kind of a guideline that everybody can follow when a university, for example, organizes a new bachelor's degree on AI. So if you go to the IDA webpage, you can have a look at the IDA AI curriculum. And then we have educational offers. So far we deliver about 90 short courses, and we have delivered 4 summer schools last summer, and we continue having new activities this winter as well. Here is just a list of various topics that have been done recently. For example, we have NVIDIA short courses on GPU programming, that is cutting edge technology for AI programming for engineers. And we collect statistics for each course because we want to see if our students are satisfied and what we do to improve IDA courses. And then we have the Excellence Lecture Series. These lectures are delivered by top AI scientists from all over the world. We delivered so far about 60 electronic lectures. You can attend them through the web, and they are for free. And on the average, we have about 100 attendees per lecture, which is very good because the lectures are very well attended, and there is discussion that follows. As we see here, we have a steep increase on the number of IDA students, IDA courses, and IDA lectures that we offered in the last 3 years. We started in late 2021, and we are already 3 years old, but nevertheless, we had a rather impressive growth in terms of all these numbers. And then we have educational resources. This means that we try to collect in IDA educational material at high level, and we curate it. This means that since this is a very fast evolving field, we remove old material or we correct material and then solve this current. And you can go there, and if you want to enter a new topic on AI, then you can find enough material to start new research in a particular AI topic. So far, we have 22 IDA curators that curate this material. And then we have the IDA web portal, and most probably some of you already entered into this web page. It contains all information related to IDA, how you can join IDA, how you can register in IDA short courses and summer schools, and how you can attend AI lectures, get AI educational material, and so on. And in the framework of IDA, we organized the so-called AI Melodology Symposium. Essentially, melon is a Greek word for future. So we debate future aspects of AI because AI is moving very fast, and we try somehow to forecast what's going on. And this forecast can be difficult because sometimes, there are people that are technophobic. They are afraid of AI, but there are other people that are too much enthusiastic about AI, which is also a problem, because AI is a tool. It can solve some of our needs, but it cannot solve all our problems. So we have to be careful on how we project the development of this technology and how this technology is going to meet the societal needs. As you know, I'm chair of IDA. I had to communicate with people from 60 universities across different domains, ranging from medicine to geology to linguistic studies to education. And to do this, I had to think about myself on what are all these aspects of AI applications, and when I want to think about the topic, then I write things down. And then I have produced a book on AI science and engineering and its application to society. I have some leaflets over there. It's a four-volume book. The first volume is AI made simple so that it's understood by everybody. Second volume is about AI and human intelligence, brain. Third volume is AI applications on society, on education, for example, on geopolitics, on religion, on war, because the drones are weapons, can be used as weapons these days, as you know. And then the fourth volume is about AI in the environment, because we use AI to address natural disasters, for example, or we can use AI, hopefully, to address climate change and so on. So if you're interested in any of these topics, you are welcome to have a leaflet and get the book through Amazon. Then IDA sponsors various events in all these topics that I mentioned you, and our next big event is going to be in July, which is going to be both a symposium and short courses on anything related to AI education. We've been very active in Twitter, and we attract a lot of publicity, and this is very important because this helps us a lot in promoting the IDA courses. So any of you, for example, that wants to offer an AI course, you can do it on your own through your university. But if you cooperate with IDA and make it an IDA course, then this is for free, first of all. Then you have a stamp of quality that your course is of good quality, because when we approve an IDA course, we do it on we check the quality of the lecturer and the quality of the material, and then we help you in disseminating this event. See here, for example, that was an event back in 2022. So the organizers, I don't know why the pointer doesn't work. Anyway, the organizers, they have done their own campaign, but they could not have a large number of registrants. Then we jumped in, and you see we had an almost sevenfold increase in the number of registrants within a week. So because we have electronic communication channels that reach about 50,000 AI students, AI scientists all over the world. So if you want to offer a short course and it becomes an IDA course, then you can promote it in the international community. That's the idea. And there's no need to offer this short course in Greece. You can offer it here. And you can make it open to the international audience, either by people coming here or by organizing it as a hybrid event. So you can let people join through Zoom, for example. Then we try to disseminate IDA in various events all over the world. One particular topic of interest is AI university education, because right now AI is important for any scientific discipline, and it's university education. For example, it has a very big impact on linguistic studies, because without AI nowadays you cannot really do linguistic studies anymore. It has applications in education, maybe human education and machine human intelligence and machine intelligence, and human education and machine learning can have some parallels. These are things to be debated. It has applications in medicine, because, for example, there wouldn't be any COVID vaccine done very fast without AI, and we use AI for protein folding. We had very well attended events. Again, as you see, there was a special workshop organized in Amsterdam on LLMs, large language models like ChatGPT, and foundational models that are used in promoting AI these days. And the general idea is to get involved. So your university can become an IDA member, but also you can get involved in IDA on a personal capacity. You can offer an IDA course, for example. or you can become an IDA curator for curating educational material, or you can try to create a regional hub on AI education here in the Middle East, because Middle East has its own particular application domains. For example, I was just talking some minutes ago that we have a project on how you can use drone imaging and AI to do surveillance of oil refineries, because there are many pipelines there. It's difficult to inspect their status for maintenance. You can use drones and computer vision to do these things. And this is a special application that has a particular interest in this region. There are other applications, societal applications, for example, of AI that are also of interest to Middle East. So you can initiate things together with, let's say, Emirati universities and try to become a regional AI hub on education. That's something that's very welcome on our side if we can help you in this. So that's all. That was the first lecture on AI. I don't know if it's time to get questions on IDA, and then I proceed to the second lecture. I prefer, if there are questions on IDA, then better discuss them now, and then I go to the next lecture. This is a little bit different. The AI education taxonomy means that we structure an AI curriculum. So which are the AI topics that should be taught? For example, machine learning, computer vision, natural language processing. So all these are parts of the taxonomy. And if you want to build a bachelor's degree or a master's degree on AI, it's a good thing to follow this taxonomy. But this concerns only departments of computer science, departments of electrical engineering, and possibly new departments on AI. Now, if we go to AI and education, this is a completely different topic, and it has various aspects. First of all, what's going to happen with AI university education? Let's suppose that you are in a department of Arab linguistic studies, okay? Or let's suppose that you are in a department of education. Then you see these tools being used already in education, like ChatGPT. You see that large language models being used to research in linguistics, and you don't know how these things are done. And typically, such people that are in such departments, they don't have the mathematical background to follow these tools. And then they are afraid of these tools because they cannot master them, okay? So there should be a big shift, in my view, in the education or in all domains, so that at least the more gifted students get an exposure to mathematics and computer science. And then you can understand what's data, you can understand what's data analysis, you can understand what's statistics, because AI nowadays is statistical machine learning. And then you try to apply them on a particular discipline. For example, how I can use AI in medicine, how we can use AI in law. And then you don't afraid these things anymore. And so that's the idea about the AI education at the university level, okay? And now the question is, what's going to happen with AI education in high schools, for example, even in primary schools? And then there is a big issue because, I explain in my book all these topics. The entire society should understand what's AI, because if people understand what's AI, then they are not afraid anymore of AI. And this is a very good thing, because a society that is afraid of things like of technology is not a healthy society. So we should educate people to understand the basics of AI. And then AI is very complicated at university level, but we are lucky because some of the basic AI ideas are very simple. And for example, how you can collect similar things together, how you can distinguish one group of things from another group of things. These are very basic ideas that you can even teach them at the primary school, okay? But at the same time, they are the basic ideas of AI. So you can start teaching people these ideas from the primary school to high school with a little bit more mathematics, and then at the university level with more mathematics, and then the transition is smooth. And then people understand that, for example, I don't know which of you have mathematical background, people can understand that essentially nowadays AI is nothing more than approximating a function. So if you know what's a function, and if you know how to approximate the function, that's AI. ChatGPT is exactly this thing. But even, scientists like myself, they don't understand this very clearly. They don't convey this message clearly. Even scientists these days are technophobic. And then people get confused. So we should educate ourselves as scientists, we should educate the society, and you should educate future citizens and future scientists. This is our only hope, because otherwise we're going to collapse.
Thank you very much.
You're welcome. So the topic of my main lecture here is about sensing and big data analytics for natural disaster management. And as you're going to see, I concentrate on two major natural disasters. One is floods, and the other one is forest fires, because in the Mediterranean region that we live, but all over the world, you see that there are huge fires these days, and there are huge floods because primarily of the climate change. So we have to see what we can do and how we can use data to manage these events, because they are even more, they occur very often these days. So the problem with natural disasters is that we have big data, and we have, first of all, heterogeneous extreme data sources. We have satellite images, we have topographical data, we have meteorological data, we have drones and other ground devices that move around and take pictures. We have people that are close to the affected areas, and they use their mobiles to take images, and they also write text about what they perceive about the event, and this is valuable information as well, because each mobile device is also a sensor. We have multilingual data, because if you are in a tourist area like Greece, then you have text, tweets in Greek, but you have also tweets in German and English and Arabic maybe. And then we have to collect this huge amount of heterogeneous data, analyze it in real time, and feed it to the Natural Disaster Management Authority, because if you don't do it properly, then they are just flooded by data that they don't know what to do with them. So that's exactly the topic of TEMA. It's a European community-funded project. We have about 20 partners, and I'm the leader of this project. And the aim of this project is to do better natural disaster management for forest fires and floods. And this means that we collect all these big data that I've told you, we map them properly, we try to predict the evolution of the event. This is physics, because how fire propagates is physics, how floods emerge, this is hydraulics, this is physics as well. So and then we present all of this information to the management authorities to take the best possible decisions for the event. Here you see the various sources of data that we have: drone images, satellite images, and also images coming from social media, images coming from firefighter units, images come from aircraft that try to combat forest fires. All this information comes to the command center, and it should be analyzed and presented in a proper way, because otherwise, as I've told you, they're just flooded by information. So the idea, first of all, is what are the natural disaster management concepts and objectives. That's the first thing I'm going to tell you. Then I'm going to tell you a few things on how we can sense those data, how we can analyze these data, and we start with the general concept. First of all, we have data sources on the left-hand side. Satellite images, for example, smart sensors, social media, and so on. Then we have analytics. We analyze all those data, and there are various information sources, so we have to fuse this information once we analyze it. And we have to geotag it, because they should be referenced to particular geographical locations where this event takes place. And then you feed this to phenomenon modeling. Let's suppose that you can map exactly where a flood occurs right now, how this flood is going to expand or recede in the future, or how a forest fire is going to propagate in the future. And then you have an interactive, you put all these things on a digital twin. This is a 3D model with layers of information, and then you use visualization techniques to visualize these data by the firefighters, for example, or the natural disaster management authorities, and then you do response planning and recommendations. How you're going to evacuate an area that is affected, for example, which are the best routes for evacuation. So extreme data analytics is one topic. Emergency phenomenon modeling, that's physics, it's another topic. And regarding now extreme data analytics, first of all, we have to have trustworthiness, because the system that we're going to develop should be trustworthy. This means that it should be no errors in data analysis. We should have increased accuracy for data analysis, and this is not easy, because most of these techniques that we use for data analytics are machine learning based, and machine learning algorithms do make errors, so we have to increase accuracy. For example, when we detect humans in danger, then we should not create many false alarms, and we should not miss people that are in danger and we just don't recognize it. And everything should be done in a very fast way. And to do this, these are, heavy computations. Some of them can be done at the edge. This means on drone. So you can do analysis, you can track a person, you can track a vehicle on drone. But in other cases, for example, for flood modeling, you have to send this data to the cloud, do analysis and prediction there, and then get back the results. So you have to serve the entire cloud-to-edge continuum for data analysis. And here you see the type of images that we work with and the analysis results that we can have. As I've told you, we have to increase the model-based prediction responsiveness, and we have to increase the accuracy, because we have to know how meteorological data, for example, affect the accuracy of predicting a forest fire. Winds, the wind speed, and also direction could greatly affect the accuracy of fire modeling. And then we should have new visualization mechanisms for evolving these phenomena, because we have such a wealth of information. Even if we analyze it, even if we put it on digital twin, then we have to present it in a way that does not overload the human operators, because human operators are humans that manage the disaster management. They are tired, and you should not overload them more than you should. And typically, in such cases, we have a number of sensors number of drones, how they fly over the affected area, what type of data they collect. This should be best done in an automatic way so that the humans concentrate on more critical decisions after data analysis rather than concentrate on how to acquire data about the disaster. We have latency issues in natural disaster management. Sometimes this is just a matter of minutes or at most matter of hours because situations change dramatically from hour to hour, and you shouldn't have delays in taking decisions. You should have, the authorities should have situational awareness of the event, how big the event is, whether there's a danger to human life, and so on. As I've told you, we have to reduce the mental load for the human operators. And these are all concepts that we develop within TEMA, and we use proper visualization, simulation, visualization tools for this. And now I'm going to tell you a few things about the type of data that we're going to collect. In the case of natural disasters, first of all, we have GPS data. That's very important for geolocalizing the events. If we use RTK GPS, then we have extremely good accuracy, and sometimes this is important when we're interested about localizing vehicles or localizing humans, and the precision, geographical precision is very important. Sometimes we do put GPS target tracking systems on certain targets, for example, firefighter units, so that we know precisely where they are when they fight, let's say, a forest fire, so that they are out of harm's way. When it comes now to drones, and we use IMUs, which are inertial measurement units, because GPS can provide X, Y, and Z coordinates or geographical coordinates, but it cannot provide the orientation of a drone. It cannot provide the orientation of the vehicle. So you need IMUs particularly for drones to show the orientation of the drone. And then drones and other vehicles have the so-called visual payload. This means a number of sensors for collecting data. Monocular images are such a thing. Essentially, if we just have a one calibrated monocular image, we can understand where is the direction of a source. So we know that along this direction there is a fire, but how far away along this direction is, we don't know exactly. So we lack depth information in the case of monocular images. So essentially, if we have a point over there, then we can cast a ray, and along that ray, there is somewhere this point in the world. But we can do this for same thing, for another point, and so on. But we cannot model the 3D world just by calibrating monocular images. So if we want really to have depth information, this is the way to do this, is through stereo imaging. You have two cameras and you get two images, and then essentially you have one ray being casted from one camera, another ray being casted by another camera, and the point where they intersect over there is the 3D position of the target in the world. So you can use stereo imaging. It's a classical technique in surveillance engineering for acquiring depth information and for mapping, for 3D world mapping. Then when it comes to moving things, we use video to record moving vehicles, to record the forest fire, how it moves over time in the world. But when it comes to video, it's huge information. So we have other types of cameras that compress this information. Event cameras, for example, measure only the scene motion. Here you see a moving person. This is only this information that is captured by event cameras. So, for example, here, this is what you record by a regular camera, and this is what you record by the event camera on the right-hand side. It's much less information that you record. If you want to create a 3D model of the world, then one way to do this is through laser scanning. So essentially, you cast a laser ray, you know the direction of the ray, you measure the reflection, and then you map this 3D point over there, and then you can do it from another point, another point, another point, and you create a 3D point cloud of the world. So this is how leaders work. Also, you use lasers, in the case of drones, to find distances in a sort of a laser altimeter way. You have the drone here, you want to land, you don't know how far you are away from the ground level, so you use laser altimeter, you cast a ray towards the ground, you get the reflection, and then you know that you are 30 meters above the ground level. Leaders create 3D models of the world. So essentially, the 3D models of the world are 3D point clouds. I've told you how they are created using leaders. They're quite good in getting information. They can be used to get depth information for depth segmentation, for example. We can model 3D information using octomaps or triangulated surfaces. There are some issues if there is rain or if there are clouds, then we have light refraction problems. But generally speaking, laser scan technology works very well. In the case of forests, for example, we can find the canopy using lasers. And this means that we can calculate the amount of wood that influences the evolution of a forest fire. Or in some cases, you can model also what happens beneath the canopy of the trees. I have just read yesterday that a student studied in Mexico, studied such types of images, and he found a buried Mayan city below the canopy using such laser data scans. And then we can have also infrared measurements that are, we can have infrared cameras. You know, if we have forest fires, we have smoke, we cannot see through the smoke if we have visible camera, but if we have infrared camera, then the infrared imaging penetrates the smoke, and you can see the actual forest fire source. And we can have optical fire detection systems that can both infrared, that can have both infrared imaging and the visible imaging. When it comes now to smoke only, then we have various ways to image the smoke. For example, we can detect the absorption or scattering of a light. This means that we transmit a laser beam, and according to how it's absorbed or scattered, then we can calculate we can do smoke detection. We have also other ways to do smoke detection, for example, using radioactive elements that, because the fire aerosols change the ionization. This is the typical way that we use for smoke detection within buildings. It's difficult to use these things outdoors. We use LIDAR for smoke detection, and by doing so we can find smoke sources in an area of about 5 kilometers around the position of the LIDAR smoke detector. And then when it comes to meteorological sensors, we need wind sensors, temperature sensors, and humidity sensors. Some of them can be put on mobile devices. Drones, for example, typically in affected areas where there is suspicion of flooding, you use ground sensors for meteorological measurements. So you have a meteorological station here and there in a grid. In the classical way that meteorologists do things, and you collect data, and you feed your flood modeling software using those data. Now, when it comes to machines that observe natural disasters, drones is natural technology. They're cheap. You can put various sensors on such drones for natural disaster observations. For example, you can have those types of cameras that are both infrared and visible cameras, and they are on a gimbal. And you can fly the drone, and you can image both the visible images and infrared images. There are various types of such images. They're not that heavy, so they can be ported by a drone. But of course, drones have the problem of batteries. You can fly a drone for, let's say, a quarter of an hour, 20 minutes, half an hour, but that's about it. Then it has to come back to change batteries. So this means that you have to have a swarm of drones that alternate each other for continuous event monitoring. And then you can have tethered drones. In tethered drones, the drone flies, but it's connected with a cable to the ground, and this means that it can fly forever. And it does not really have problems with the wind, and it goes high up, let's say 30 meters, and then it can observe the Earth from that angle. It's very easy. There were some efforts to use drones to extinguish fires, but so far not much has been done in this respect, primarily because drones cannot carry much water to do firefighting. But there are autonomous airplanes that can have up to 10 tons payload capacity for water for extinguishing fires. They are experimental, though, at this point. And then we have autonomous firefighting vehicles. There's much work that has been done with ground vehicles and robots these days, but not as much as it's needed for natural disaster management. This is an issue because, in Greece, for example, we have fatalities every year amongst the firefighters because they get too close to the forest fire, and then they burn themselves. So instead of doing these things, it's an easier thing to use autonomous devices, autonomous robots. There are some experimental units, but they are just experimental. So they're not in massive production. And there are issues because, such machines should move around in rugged terrain, and it's, from the robotic point of view, their control is not easy. And now we go to analytics. We collected our data through sensing, and we have to analyze them. So how this is done? In most cases, we use deep neural network and computer vision technologies to detect things, detect humans, for example, detect cars, or segment flooded areas, or segment smoke areas and forest fire areas. And then we have also social media analytics. For example, you collect tweets. And some tweets come from a particular location, and people there are in panic because they are close they are in a flooded area. How can you detect panic in tweets and use it to go there and save these people? We have, of course, trustworthy analytic issues. For example, how accurate our models are, how we can protect privacy, how we can explain robot decisions in case of a legal dispute after the event in a court, and how we can fuse these things and how we can visualize our data. One problem is obviously detection. Here you see what we have done in a flooded area in Greece. we used object detection to detect cars in a flooded area, and we monitor them because maybe there are still humans in there in danger. Another thing here is to detect humans in a flooded area. Again, it's different from classical human detection because people are half submerged in the water. And then we have segmentation of crowd areas. Sometimes, people in case of danger, they cluster each other in crowd. So you have to detect where there is a crowd in an area that is in danger, because this is priority. You go and save many people at the same time. Here you see this is not really related to natural disaster, but you can say that we have segmented the crowd area fairly well without many false alarms. This is a concert actually in Bristol. Here we have segmented the flooded area. That was from a flood in Greece some years ago that was very deadly. So what you see in brown color is segmented flood region. And then we have fire detection issues. We have to find the new, essentially fire detection, we find bounding boxes that show where the fire is. And we have issues with the classical mean average precision metrics for measuring the performance of our algorithms. That because the classical object detection is performed on rigid, non-deformable objects, cars, for example. But fires and floods are not the same thing, because fires are they are not essentially an object. We call them an object, but they are regions that are highly deformable, and they change over time. So we have to define new metrics on how to measure performance in the case of fire detection. And we have done this. We have detected even very small fire sources in the presence of smoke, and the mean average precision that we get is very good. And then the question is how we can develop new vision transformers for doing fire detection. And we have modified VIT, and we have better performance. We have an increase in performance of about 3% through our research. Then we have issues related to smoke and to forest fire detection. And there are two reasons for detecting smoke. One is that sometimes only smoke is visible. For example, in the upper right corner, we see only smoke, but we don't see any fire yet. There is a fire, so we have to detect it through smoke detection. And in other areas, like in the right-hand side to the lower part, we have both fire sources and smoke, and sometimes smoke obscures the fire sources. Over there, for example, you can see such cases. So we can use infrared and visible images, joint analysis, to perform both smoke detection segmentation and fire detection segmentation. By the way, maybe here in Oman you don't have such problems with forest fires, but exactly the same techniques can be applied in industrial environments, because if you have an industrial fire, then in an oil refinery, for example, then you have exactly the same problem. You have to localize the fire source, and you have to localize the smoke, but in a different setting, of course. Then we have tested and developed new techniques for using DNS to segment fire regions. For example, over there, though it's in winter time in Finland, there are some fire sources, and we could detect it, and also not only detect but also segment the regions where these fire sources were. And when it comes to accuracy, we developed our own accuracy measures to define how good our fire segmentation is, and we have performed very well, and we have reported in publications. Then similar things, we have, as in our university, we have worked with drone images. But in DLR, this is the German Aerospace Institute, they work on satellite images. So you do the same thing for satellite images, and you see the active forest fires that exist at a certain point all over the world, or you can go to Portugal and see how the forest fire evolves over time. This is the analysis that typically do on satellite images. And to do this, of course, they get satellite images like that one in Peloponnese in Greece. You see we had various fire sources over there, and the smoke is visible from satellites, and we use this information to detect and also to segment the burned areas. Here on the left-hand side with red, you see the burned areas as seen from the satellite. And then we have to perform georegistration, because if we have pre-event images, let's say the event of a forest fire, and then we have images before, images after it, and then we have to match those two things to assess the damage. Here, for example, you have on the right-hand image an area in the US, and also the same area burned, and we have to establish the relation between the two, so we find correspondences, and we can assess the damage this way. Which percentage of the images has been destroyed by fire. Same thing here, we have images before and after the event, and we can find correspondences to see which areas have been affected after the event. Now, once we have done forest fire imaging, we know where is the actual wavefront of the fire, then we can feed this information into the forest fire modeling software that is provided by Tecnosilva. It's a company that is partner in the TEMA project. So essentially, we use meteorological measurements. We know the actual fire front at a certain position, and then we try to model and predict the evolution of the phenomenon based on meteorological condition, based on the terrain model, and based also on the wood that is available in this area, because forest fires burn wood. So we have to know the level of wood coverage in a particular area. So here you see, for example, that we have wind from that area. On the right-hand side, where we have the current forest fire source, and then we see how we predict this is going to evolve over time, based on wind measurements and also based on the terrain model. And we have to calibrate the simulation, because this simulation of a forest fire, and to do this you have to do information fusion as well with meteorological parameters and so on. Now we move to another natural disaster, which is floods. And then we have two types of floods. We have regular floods and we have flash floods. Flash floods are streams of water that go through wadis, let's say here, and then they create havoc. It's mostly a dynamic phenomenon. On the other hand, regional floods they just flood an area that is, and the water stays there for a number of days. So here we needed data to where we should develop our algorithms, and this is why we created the so-called FloodSeg data set to perform flood segmentation. So we have a number of images and videos that we have collected, we have analyzed it, and we have created ground truth to be used for training our machine learning algorithms. We have employed two different CNN architectures for flood segmentation. One is a combination of BiSnet network and ResNet 18 as a backbone. The other one is PSPNet, that is a benchmark model for semantic image segmentation tasks. Also we have used some supervised learning because creating ground truth segmented regions is too much intensive. So we try to use as much unsupervised techniques as possible. This means to use flood images without ground truth, without segmentation. And you see that we have developed techniques that have very good performance in terms of both the speed, so speed is faster than real time, and also they have very good accuracy in segmenting flooded images. Here, for example, you see that we have flooded images and we have the ground truth in the middle, and then on the right-hand side you have the DNA result. There is a very close match between the ground truth and the predicted and the DNA output. Here again, with this purple color, we show the flood water that has been segmented. We have very good accuracy as well in segmenting those images. And then another issue is to do object detection and tracking. We concentrate on two things: humans that we want to detect and cars. And we have performed fine-tuning of our DNN models for both car and person detection, and the accuracy is very good. We have done all of these things on drone images, but you can do the same thing at a different level on satellite images. Here, for example, on the lower right-hand side is the Thessaly region in Greece. A year ago, we had severe floods there, and this is the images that have been analyzed by DLR, and they show with green the flooded areas. There was a huge area that was flooded because there were severe rains due to climate change. And of course, you can combine both satellite image analysis and drone image analysis. Here you have drone images. You can combine it with satellite images to do more precise localization of the flood effects and the damage that is done. Once you know your initial conditions, you know, for example, when it's going to rain and how much is going to rain, then you can start simulating the flood development. And this is what was done by Nellen and Schumans. That is a company, Dutch company that works on hydrodynamic simulation, and as I've told you, they have business also here in cooperation with the Oman government for flood flash management. You have all this information coming from various types of sources. Drone images, satellite images, social media tweets, and so on. How are you going to visualize it? To visualize it, you need the so-called digital twin, which is a 3D model of an affected area. So you see how we have flown a drone over the city of Larissa that was flooded a year ago, and we have used these images with structure from motion techniques to create the 3D model of the flooded city. And Nordox, that has done this analysis, he has provided drone imaging rules so that a person, a firefighter that flies the drone, he or she is a firefighter or a pilot, he should know how to fly the drone and take overlapping images to cover an entire area. For example, here on the left-hand side, we see a red roof. This red roof should be visible from different positions so that it can be 3D modeled. And we have other cases where we have just one point of interest, for example, a small forest fire, and the drone flies around this small object in a circular orbit to image this object. Again, the pilot should be quite capable to do this, or we should use automatic drone flight to perform this. And that's the type of 3D models that we have created. So if you use state-of-the-art algorithms, the performance is not that good. But if you use more sophisticated structure for motion techniques, then you can improve the performance of your 3D model. When it comes to social media analytics, first of all, it's tweets that people use to communicate information. So we do natural language processing, which is an AI method, for two things. First of all, to find the topic of a tweet discussion. Let's say the topic is a flood in Israel, for example, okay? So you have to detect the topic automatically. And this is done by University of Salzburg. Then on top of it, we have to do text sentiment analysis. Okay, we have 100 tweets from a particular region here. What they are all about? Are they neutral? They just comment about the flood? Do they show any fear? Or do they show panic? Because if they show panic, then you have to act immediately and go and save these people, okay? So, and this is done automatically. So you feed these tweets in an algorithm, and through NLP you do text sentiment analysis, and you feed this information to the system. And we have very good accuracy in classifying the sentiments of particular tweets for a hurricane database, and also in the case of COVID, because again, in the case of COVID, we had tweets that were related to stress. Once you do topic analysis and the sentiment analysis of the tweets, then you can geolocalize them. For example, you can say that we have hotspots in the US, in northeastern US, in Florida, and also in the western coast. That was about COVID, but you can do the same type of geolocalization also for natural disasters. And then, as I've told you, we have a number of information sources. We can have tweet data that have been georeferenced and analyzed. We have thermal and infrared images, we have satellite images, we have fire simulations. We have to fuse all this information. This is done by University of Seville because one modality can help the other one to get better recognition. And they have developed a georeference probabilistic method for doing information fusion. Sometimes, you know, when you have systems, DNS systems that take decisions, then these decisions should be explainable. Let's suppose that there is a drone that overflies an area. In that area there was a human in danger. For some reason our computer vision algorithm did not work properly, and we missed this person and this person was drowned, okay? And then this case goes to court. Why there was such a failure? There should be an explanation why drone failed to spot this particular human. And this means that we need DNN explainability. This is research by Fraunhofer Institute, HHI. It's a very important topic, DNN explainability, and they work around concepts. For example, when a drone sees an image, then the DNN that analyzes drone images should understand certain concepts. For example, it should understand that the concept of a fire, the concept of a person. And based on these concepts, it can provide an explanation, hopefully in a human understandable format, so that you can give this explanation to the judge and you can say that this drone failed to spot this particular human. It actually spotted this particular human, but it failed to spot the fire for a reason, because we have also errors in the case of drones. And then you have an explanation. Whether it's good enough for the judge or not, that's another story. This is a legal issue. There are other things that now related to humans, because in natural disasters it's humans that were concerned mostly. So we have to identify and re-identify humans. For example, let's suppose we find the human once, but then the same human appears after, let's say, a quarter of an hour, and you want to measure how many humans are there in an affected area. You should not count the same person twice because it appears in the video twice. You have to re-identify that it's the same person, and you count two person appearances as one person. So this is work done by authors. And then another issue is privacy protection. Okay, privacy is not really the main thing in natural disaster management, but it's a good thing to protect privacy nevertheless. Actually, in the European Union GDPR legislation on privacy protection, there's no distinction between other images and natural disaster management images. So we have to anonymize facial images. And hopefully we can do it in a reversible way, because if things go to court, then you should not have destroyed evidence. So you should reverse the process and make things, persons clear again to be used in the case of a judge. And we have developed several techniques for privacy protection that are reversible or non-reversible. So this is an active research area. And though it's a social issue, privacy protection, it's again based on machine learning techniques. So that's all about big NDM data analytics. I'm just going to say a few words about TEMA. It's a big project with 12 million euros budget. We have 12 partners, 19 partners from all over Europe. There is room for cooperation with you. For example, we actually do need data. So if you have flash flood data here in Oman, and you can go and tag them and provide them to us, then we can co-publish a database on annotated flash image data. This is something that's useful for the international community. Now, in the case of our lab, we mostly work on computer vision, machine learning. We have been active in the last almost 40 years in this area, because I'm close to retirement. We have a very large number of publications, a good science citation index, and we had a large number of R&D projects. In a sense, we're a rich lab because we have a lot of funding, research funding. So if you have good PhD students or researchers that want to work with us for a shorter or longer period, it's a little bit complicated because of visa issues, but I think that we can handle this. So if you have knowledgeable students of yours that want to come and work with us for a short period, they are welcome to come, preferably if they have computer science and or electrical engineering background. As I've told you, we have many open postdoc positions, PhD positions, master's positions, and also short young researcher visits. And I already told you about IDA. This is another possibility for cooperation between your university and our university. I would like to thank this project and the various partners on this project that contributed to this material, because whatever represented you here, it's not only our work, it's work of other universities and other companies across Europe in the framework of the same project. And that's all. Thank you very much.
Thank you so much, Prof. Yunus, for this insightful presentation.
Thank you, Mr. Ioannis. My question is about the model of the big data analysis for the application of the flash floods in Oman. So let's say that we use this model as a detection. So we have, for example, flash flood, or we call them wadis, and it's covering a certain area at this time, at this current flash flood. So is the model, or can the model be used as an alarming system for the next flash flood? Because what happens in Oman is every time we have the flash floods, the surface changes or the topography changes. So we have an accumulation of sediments in some areas, and the sediments or the old sediments go away from the old flash flood. So does the model work as an alarming system for a changing topography for the next flash flood?
You know, the reply is yes and no in the following sense. If you have a certain meteorological pattern about the prediction of the rain, where it's going to fall, this pattern can be repeated in the future. But the terrain model changes, as you already told, after each flood. So the general modeling work is still valid. So more or less you can predict what's going to happen, but the accuracy of the model is going to be lower. If you want to increase the accuracy of the model, then you have to have current meteorological measurements and predictions as best as possible. And it's a good idea for areas of great importance, because of, let's say, there is a city that's close by to the flash flood, then after a big flash flood, you go and remap the area. It's not that difficult anymore, because we've done it and we're going to do this again. You just fly a drone over this area, and you have the old 3D model. You fly the drone, you map the new data, and you update the 3D model, and then you run your experiment. This means that if, for example, the width of the river has increased a little bit, then this can be taken into account in modeling, and then the accuracy is going to be much better.
عبد الله, thank you. شكرا جزيلا in Arabic. ساسف شريستو.
Thank you very much.
I have a general and simple question. It's about not regarding the lectures, but as you are leading scientist in AI, and as you know, it offers us a lot of great benefits, as well as huge risks, such as bias, discrimination, lack of transparency, job displacement, and also ethical concerns. Do you foresee any hope in the future that there will be a body or someone in this universe here that will be able to reach to address such big issues, like these key issues in the AI field?
Okay, it's a very interesting philosophical, let's say, question. The first question is why we need AI, okay? And the real reason why we need AI is the following one. Our world becomes ever more complex. For example, our cities are more complex. Muscat was not like this 50 years ago. It's much more complicated now, okay? Also, our mental world is more complicated. In the past, let's say, 20 years ago, we didn't have the notion of internet, we did not have the notion of cybercrime, we did not have the notion of cryptocurrencies and so on. So we have an increase in our mental world, okay? And also, and then the question is, and we collect a lot of data. We have sensors everywhere. Each mobile phone is a sensor, okay, essentially. So we have billions of mobile phones and billions of sensing information. How can we analyze those data? And the reply is that without AI, you cannot do it. So essentially AI is a blessing to the humanity. Now, why our society becomes more complex, this is a very interesting philosophical question. We can discuss it, and in the July symposium, we have a particular workshop exactly on this topic, why our world becomes ever more complex. There should be a reply to this. It's not an easy reply, okay, because it has to do with physics, it has to do with biology, psychology, sociology, so it's economics, it's a multifaceted question. But given that the world complexity increases, then AI is our reply to the increase of the world complexity, okay? Now, is everything fine? Not really, because the way you use this technology is the same with the way humanity used technology. You have a knife, you can cut bread, but you can cut the throat of a person, okay? So it's the same issue existed for thousands of years, okay? Same with AI. You can have very bad use of AI technology these days. Let me give you an example. Let's suppose that, a terrorist goes and in somewhere in a market and blows himself up, and then there are lots of fatalities, okay? That was the old way that terrorism was done. The new way, there's no reason for him or her to die. She or he can send a drone loaded with weapons in the market, and then it explodes, and that's it. You can see it's a paradigm shift of the dangers of AI. Or you can use fake news to defame people. And this happens in my country, for example. Young kids, they create nude pictures of each other, they post it in the internet, and it's very simple because they pay a few dollars to buy some software, and then they create big family problems to the young ladies that see themselves nude in social media. Then what's the reply? There are dangers, okay? In my view, there are two replies. First of all, we should regulate AI. We cannot leave it as is. And we have a failed example in this respect. Social media was not regulated early enough. And then it exploded, and now we have problems. I don't know what's the situation in Oman, but in Western Europe and in the US, young people use too much social media in an uncontrolled way, and this creates mental disorders for them. So we should not let this happen again with AI. That's thing number one, regulation. But always regulation is one step behind technology.
Who should do that?
Governments. And it's not only it's not only one government. This is a type of an international problem, you know, because a family in Greece may affect it, but the company that creates this issue, the fake news, may be in China or it may be in Oman. So there should be a type of an international treaty. And these treaties, you know, they are too slow to develop. So this is why technology is always ahead, and the regulation, especially international regulation, follows. Well, then is there any other hope? My belief is that the real hope is education. So people should be educated. First of all, not to be afraid of this technology, how to use it properly, and how to use it in an honest and democratic way. Because, you know, without people's education, there is no real hope. Because there are always going to be bad guys, but if the majority are honest, there is a hope. If the majority are ignorant people, they don't know what's going on, and we have bad guys, then this is a disaster, and we have technophobia. This is, to me, the real danger for the future of humanity. So we have great prospects ahead of us. AI is our brainchild, so why should be bad against us? But we have to be very careful.
Well, thank you very much for presentation. I have a comment and a question. People, you mentioned terrorists exploding themselves or using a drone and killing innocents. It depends the way you consider it, but to much extent we have seen also using AI in targeting civilians in the recent times. So that is also terrorist. But my question is, you have mentioned about education. Yes, I agree with you, education is very important. What do you think about where a university can start when it comes to AI?
So
the first was a comment.
Let's discuss both, okay? AI can be a weapon. Actually, it is a weapon. And actually, intelligent weapons that we use them nowadays, being used in Palestine or being used in Ukraine, all these intelligent weapons use AI. They use, person tracking capabilities. The same thing that I've shown you here, they can be used for military purpose. Exactly the same. And this can be very dangerous. It is already dangerous because it costs people's lives. It can be much more dangerous in the future because, let's suppose that such a drone has a small failure in its software, okay? And it starts detecting and killing people indiscriminately. Even, your own people, because there was just a failure. This is, and then the question is, who decides to kill? Are you going to let a machine to decide to kill? So there should be a regulation on how we use these weapons in the future. In the past, we had such problems with nuclear bombs, but nuclear bombs, they belonged to countries, big countries actually, and it was much easier to regulate the use of nuclear bombs. And luckily, we didn't have any problem after the Second World War. Now, this technology of intelligent weapons, it's a poor man's technology. This means that smaller countries, bigger countries, they can use autonomous drones for doing war, and then things can get out of control very easily at a heavy cost. And so that's why this is one more reason why we need international regulations, because things can get out of control in a military concept. That's thing number one. Thing number two on AI education at university level. I think let's concentrate on the education on the university level, okay? Then there are two different things in my view. First thing is what the university should do in departments of electrical engineering and computer science, where traditionally these topics are taught. Then we see two tendencies. The new tendency that becomes ever stronger is to have new departments of AI, or to have AI bachelor studies and master studies in the context of computer science and electrical engineering. This is going to intensify. And we see many universities nowadays that have new departments of AI or new AI bachelor's degrees. In a sense, we are in the same situation with physics at the end of the 19th century. So when the first industrial revolution became mature, it was basically based on physics, mechanics, and then physics started increasing, and then it could not be one scientific discipline anymore, because out of physics we had electrical engineering, mechanical engineering, because as different disciplines. And maybe we are in the same situation now. We have computer science, it increases through specialization, and maybe at a certain point we're going to have a network science discipline or an AI science discipline, separate one, because you cannot accommodate everything under the umbrella of computer science, okay? And we see this happening. We don't know still there is debate on this issue, because even big universities like MIT, for example, and Stanford, MIT, I know that for sure, that were a little bit reluctant to enter into new departments of AI. They were thinking of AI as being a specialization of computer science. But then it seems that they changed their mind in the meanwhile. So there was a big discussion on these things in the last 2 or 3 years. And then the big question, even bigger question, is what happened with what's going to happen with the other disciplines? Education, for example, medicine. What are you going to do there? Then there are two solutions there. One solution is to have joint degrees. So you have a major degree on education and a minor one on computer science. So for people that, they want to specialize on bioinformatics, then they can have a major in medicine or biology and a minor in computer science. This is one possibility. To me, this is not really enough, because we have an increase in mathematization of all scientific disciplines. There is a reason for this. Images are pixels, and pixels are numbers. So essentially, we have transformed images early enough into numbers, vectors for the ones that have a mathematical background, okay? Speech is the same thing. We have transformed speech into numbers. That's why we communicate through mobile phones. It's all numbers, okay? So that's why we use WhatsApp, because WhatsApp works with numbers. And then the last bastion was language. Language has words, okay? In the last 10 years, we transformed words into numbers and into vectors. And this is the basis of large language models and natural language processing and ChatGPT. So essentially, we transformed words into numbers. Everything now is numbers. Once everything is numbers, you cannot process numbers without mathematics. You cannot process numbers without computer science. That's why you need such knowledge in all disciplines. This means when you have a department of medicine or department of education, you should have 3 to 4 basic mathematics and computer science courses in the education curriculum, in the mathematics curriculum. It's not easy. And is it doable? Is it superhuman? You know, this is still a debate, you know, because I was discussing with the sociology people and the psychology people. Can, let's say, linguists learn mathematics? And they don't know. I mean, there's no reply, yes or no. There's no reply whether, you know, there is a division between liberal studies and mathematics in our brain, or this division is because of our education. If it's because of our education, then this is double. We're going to change our education. But if the distinction between liberal studies and mathematics and physical studies is within our brain, the way our brain functions, then it's much more difficult to do this thing. There are some gifted people, let's say 10, 20%, 25% that are good in both. They can survive and they can excel in both worlds. But the question is what's going to happen with the rest 75%. So it's a big issue. The big challenge nowadays is on liberal studies, because the liberal studies people, they were not exposed to mathematics. So there is a huge discussion, and I don't know what's going to happen after this.
Liberal sciences, they are not exposed to mathematics. Perhaps they can be just users of artificial intelligence.
That's not enough. That's my point.
Yeah.
Not enough anymore.
Yeah. So, do you think?
So that's the classical reply, you know.
Yeah, that's why I want to make you to get more clarification on that, because I can see them very well users.
This is not good enough anymore, because if you're a linguist, for example, and you don't know natural language processing the way we computer science know it, then you don't have a future as a researcher. You don't have a future as a science, because right now there is a big paradigm shift in linguistics. In the past, you know, we knew about languages, we knew about grammar, about syntax, and this is classical linguistics, okay? You don't work, you don't do research on linguistics anymore using these terms. You do research on linguistics using tokens and vectors and those mathematical constructions that most linguists don't even know about them.
Yeah.
So it's, well, is it going to be like this in the future? In the next 10 or 20 years, yes, it's going to be like this. After that, who knows? In the medium term, short and medium term period, they have to learn mathematics, period. Whether it's doable or not, that's another story.
Well, thank you very much for very interesting presentations. And let me share with you very quick what is happening at Sultan Qaboos University. I'm very glad to hear that. I think we are on the same direction. Definitely, I really 200% agree with you, the importance of, you know, transforming numbers into the language and the importance of mathematics. If you look to our 32 elements in every degree program, these are elements identified by Sultan Qaboos University recently, just 1 year and a half. We said the importance of mathematics and simulation and using very strong theory to support any degree program. That's why, hopefully, next year, the Emerging Technology Center will be there, not dedicated for research, is supporting degree programs. And in this Emerging Technology unit, there'll be AI, big data, blockchain, cybersecurity, and cloud computing. What we are trying to do now is to say, look, the subject like statistics, mathematics, physics, and these are very, very important when we talk about humanity specialization. You are right, we were not exposed in the humanity into how to deal with vectors, numbers, and so on and so forth. So I'm happy that it is on our top priority, trying to inject this type of understanding It's not easy, as you said, changing the mindset for
Exactly.
our colleagues who are working in humanities subjects. What we are trying to do, as far that you have mentioned about education and educate people. So on the, I think it's after 2 weeks from now, we have a program which will start educating how to use AI in education and research for 1,200 individuals at Sultan Qaboos University. So that's a program which will take the whole year, but will start on the 4th and 5th of November. More than that, what we are trying to do is really, SQU have created where we stand when it comes into AI and other emerging technologies. We have adapted the 3P model. The first P is prohibition. We prohibit people, you know, so this can be a little bit strange. But the second P is permission. And the third P is promotion. We encourage people to use AI in different aspects. So we thought that that is fair, okay, in different levels of our students and faculty. Of course, he was asking about the governance and who should do that. At a university level, we have produced a document, what happens when it comes into risk associated with these emerging technologies and AI. So what people should do. But we are not saying you should not experience and use it. We are saying just use it and be careful. Exactly the way you have put it. We can see the benefits there, and we are trying to avoid the disadvantages of these emerging technologies. So what I want to say is the following. We want to lead, hopefully, higher academic institution in AI. And we have 3 levels. As consumers, using ChatGPT and other softwares, as developing small applications. You have mentioned, for example, the simple applications which can be developed at a primary school, like a comparison tools and these things. But also to go into the development of our own, or development or enhancement the AI field itself through research. So last year, or beginning of this year, an AI bachelor degree was approved in computer science department.
Very good.
And in fact, there was sort of a pull and push between computer science department and the College of Engineering. But the way we see it is a multidisciplinary approach. And maybe Dr. Talal, the Dean of Science, is there. That was the recent degree program, which was approved by University Council. Of course, we do have a master degree and a PhD program. But to us, it was not easy to get it approved at the bachelor level. So thank you very much indeed. I think we'll be collaborating with IDA. Definitely, I can see a lot of opportunities. We have plenty of things to share together, but I'll leave that to Prof. Hussein to follow it up. Thank you very much.
I'm really pleased that you have policies with respect to all the things that we discussed today. And I would be more than glad that IDA helps you, and we profit from exchanging ideas among each other. For example, because I think that the Arab world is a big world, and if you somehow can take the lead in one way or the other to promote AI education in the Arab world, then this is a very good positioning for your university. For us, you know, you can come and some of your students or colleagues can come in July in our symposium in Greece. IDA can offer courses here, either remotely or physically here in Oman, especially if it becomes something like a regional event where other people from other countries participate. We can cooperate on this. It's within the IDA plans, and after all, we're neighbors. And for me, you know, being a Greek, Greeks always, you know, had contacts with this area from ancient times. You know, Greek merchants were through the Red Sea to this area for essences, and they went even down to Malabar in India for spices from thousands of years ago. So let's revive this tradition and have good cooperation.
By AI.
Possibly, yeah, why not? Definitely.
In fact, just 2 months back, we had a summer school in AI in south of Oman, Salala, and it was very, very interesting. Definitely, we'll collaborate, and our model is very simple. We start small and accelerate very quickly, and so that there'll be commitment from both sides. Definitely, I'm sure soon or later we'll see the profile, type of programs you offer. Then we'll take it from there. And from the beginning, we discussed with Professor Hussein. When we saw that your first email, we said, okay, immediately we would like to join the organization. That's why we have applied, because from the beginning we believe that, yes.
Sorry for being slow, but I was really very busy in the last two months. So, but I'm going to finish this business soon, within November.
Yeah, in fact, thank you very much. You have initiated this visit. We didn't know about it, so thank you very much. It comes from you, and let us see the fruits of your investment and your time.
Okay.
Thank you. We have something small as a gift, a souvenir from Sultan Qaboos University, if you can come here.
Sure.
So this is our university logo, and you can see it's written in Arabic, Iqra, it means read, and this is one of our verses in our holy book, and this is, we call it, this one, a dagger khanjar.
Yeah, I've seen it in the National Museum yesterday.
Yes. So thank you very much. You want to take a photo? Yeah, okay. Just wait. Thank you. Thank you very much.
Send these photos as well.
Yeah, well, I shall do. Yusra is director of my office, and the gentleman will take you to visit some laboratories.
Okay, sure.